Funding for this program has been provided by the Southeastern Texas section of the American Chemical Society and Friends of National Chemistry Day.
Good evening, and I'd like to welcome you to a special hour-long program looking at chemistry. You've probably been hearing an awful lot about chemistry over the last few days. This is a time of the year that's been set aside for National Chemistry Day, a time when we recognize some of the contributions that have been made to society by chemists and by the chemical industry. It's appropriate that we should be looking at this subject here in our particular area. Right now we're sitting in the midst of probably the biggest chemical area in the entire world, the Texas Gulf Coast. We need to recognize the importance of the chemical industry to the state of Texas. About half of everything, that's half the dollar value of everything that's shipped out of Texas, is a chemical product, and it accounts for almost $4 billion in jobs each year here in the state of Texas. To discuss the subject and to get a better look at what is happening in the world of chemistry today and where it's headed for tomorrow, I'd like to introduce you to some of the people who we'll be talking with this evening. First of all, Karen Schubart, who is the manager of environmental protection for Dow Chemical Company, and their office is located in Freeport. And then Dr. Norman Hackerman, who is the director of research for the Robert A. Welch Foundation. That's a foundation that supports chemical research throughout the state of Texas. Then Dr. Robert Porter, who is the plant manager for the DuPont Chemical Company that is located in LaPorte. Dr. Charles Holland, who is Professor Emeritus of Chemical Engineering at Texas A&M. He is now the president of the Texas Institute for the Advancement of Chemical Technology. And Dr. John Tweeten, who was formerly with Exxon as an oil field chemist. He gave that up to go into an entirely new area. He is now an environmentalist, an author, a naturalist, and a photographer. So to begin our discussion on chemistry, it's interesting that chemistry probably provides us with an enormous area of growth here in Texas and especially here in Houston. It's important when you consider the impact that chemistry will have in just one area that's important to Houston, the aerospace industry. We have a tape that discusses some of the future applications of chemistry, especially in the area of some lightweight plastics.
In a water-filled chamber simulating weightlessness, NASA technicians connect experimental hollow struts that one day may be the external frame of a space station or huge communications array. Each two-piece strut weighs less than 8 pounds. Developed at NASA's Langley Research Center in Virginia, they're molded of what chemists call a composite, laminated plies of a plastic glue and reinforcing fibers.
In the aerospace community, composites have a tremendous advantage. They're lightweight, and they're very strong, and they're very stiff.
In composites, different fibers and chemical mixes offer different qualities and economies. Some are stronger than steel, but a fraction of the weight. For the space struts, NASA prefers a graphite composite. The struts were turned out by automation, but the same principles are demonstrated in making a panel by hand. As they wrap around a drum, the graphite fibers are saturated by a resin. Sheets of the material are then crisscrossed atop each other. After pressurized heat curing, the composite comes out a strong, chemically bonded, lightweight panel. The struts have the same properties.
Graphite composites are lighter, stiffer, and stronger, and will not expand when heated or contract when cooled.
Composites aren't just for space. They're substituting for metal in products from cars to Army helmets to golf clubs. But many aerospace chemists consider them the material of tomorrow for their many potential uses. Composites now form tail and wing sections of some airliners and jet fighters. And the space shuttle doors are made of a composite. Soon, the shuttle's booster rocket casings will be switched to a composite. Composites, strong and lightweight. How light? Well, consider the struts that may be used to form the frame of a station in space. Telescoped together, 16,000 two-piece sections could be carried by a single space shuttle.
We have a piece of that laminated plastic that Karen brought with her. It actually even sounds like metal when you tap it. Is this something that's made here in our area?
Yes, this is a piece of material made in Texas for these same applications, and there's a number of companies in Texas very much involved in the composite field. This is another example right here. This is a piece of grating made out of the composite plastics that would be used for an application where you couldn't afford to have metal because of corrosion properties, such as an offshore drilling platform. And that would be what this would be used for. Have the same strength or better than metal, but not be corrosive or subject to rust.
Another feature seems considerably lighter, too.
And it's much lighter. That's right.
Are these the
Texas
same
is
plastics
involved.
that we're seeing in automobiles and so forth?
Absolutely. New wheels are being made because of the lightness and the strength out of these composites. So Texas is going to be a big player in the future in this business.
Which brings up an interesting point. People talk about the oil industry and the loss of the oil industry, what a blow it is to the Texas economy, but everybody seems to be of a like mind in the fact that we have an equally important chemical industry that's already built up in Texas. The structure is already here. What's the future of that industry?
Oh, I think the future is very bright. I quote Dr. Holland quite often in some of his papers. He said that the petrochemical industry is the best kept secret in the state of Texas. And yet, what is it, 57%?
About 57% of all the petrochemicals are made in Texas.
In the country.
What does that mean in terms of the future?
Well, this is just the framework that we can really build a great industry on, provided we keep the climate right for industry to come here. And so it's still, if a person wants to put in a new plant, one of the best places still is to come to Texas, because he can get the raw materials he needs right here from plants that are making it. He can get it out of a pipeline, they can put it in their plant, he can sell his product, and then the products that he doesn't want, he can put back in the pipeline probably and sell it to somebody else in the network. So in order to compete with a place like that, you have to establish another complex like we have along this Gulf Coast, and that's what's expensive. So we've got a real opportunity here to grow, and with this head start on everybody else, that we've got a real opportunity for the future.
Bob, was that one of the reasons DuPont came to this part of the world?
DuPont came here back in the 1940s, primarily because of the raw material supply, transportation, and they continue to build here because of the complex. The networking that's available for all parts of the chemical industry are very significant here. Our view is that the chemistry field is going to continue to grow because it's so pervasive in all of our lifestyle. We talk about the high-tech industry, and the chemical industry is high-tech industry, whether it's in pharmaceuticals or the new electronics industry, genes. We'll see some more of those things. Developing agriculture. Chemistry is the wave for the future.
How about in terms of jobs? People seem to have the feeling that we need to go to all these exotic industries to attract them to Texas when we already have the chemical industry here. What kind of jobs are available in the future in the chemical industry?
I think Dr. Holland's the one to talk about that. That's a specific part of his interest. There is a secondary industry looking at finished goods that is not developed in Texas.
So in other words, we're developing materials, shipping them out of state to be finished somewhere else.
That's right.
There's where the real opportunity is for the Texans. We are already the high-tech chemical center of the world, this part of the country is, in making these materials. We're going through the second upgrade from crude. The third upgrade is to take it from, say, polypropylene and these chemicals that we're making, shipping out, to make those into the final products that you see today when you walk into a mall, a modern mall. Everything there you see will have come from a chemical company or been touched by it in some way, everything. In the same way in a modern room today in a house. It's hard to lay your eyes on anything that wasn't some way touched by the chemical industry, and yet most people think of chemistry just as nasty, smelly liquids.
We were talking earlier, and you made an interesting point talking about a barrel of oil, and as it goes through the different processes, what it's worth.
I'll go through that. $18 a barrel crude, when it's upgraded to gasoline, is worth about $21 a barrel. When you upgrade it to ethylene or propylene, it's worth about $54. Polyethylene, polypropylene, about $150 a barrel. And then when you convert it into final products that we have in our rooms and so forth, it's up to $840 to $2,700 a barrel. So what we've been doing in Texas, in the High-Tech Chemical Center, is shipping all these chemicals out at somewhere between $54 a barrel and $150 a barrel, and buying them back at $840 to $2,700. And that is a people-intensive industry, making them into final products. The industry that we have here is a capital-intensive industry that costs you about $1 million per direct employee to have that industry. And the other one is people-intensive, and we've got a lot of people in Texas could participate in this downstream effort. And so there's where our real opportunity is, as well as the other one. There's another 30% in the bulk chemicals coming up.
If I could ask you, Dr. Hackerman, when you look at the potentials that are available in future growth within the chemical industry here in the state, are we doing what's necessary in the areas of research and providing the environment necessary to step ahead in chemistry?
Well, if you consider what the legislature did this past year in providing a research support program, not just chemistry, of course, but a research support program, the answer is yes. We have the capacity to provide people to do the kinds of things Dr. Holland was talking about. The fact of the matter is that one of the things we've been doing is run them from the 12th grade through the 16th grade and then shipping them out to other places for finishing, and they stay where they get finished. I think we're in a position to reverse that trend, bring in the semi-finished product and finish it here, as far as chemists are concerned, and physicists and others. Furthermore, if you take that chemical industry that's been discussed here, remember, we have perhaps the biggest medical center in the world, perhaps. And if it isn't, it's very close, so it doesn't matter. And while a lot of people won't like what I say, the fact is that everything that's done over there is predominantly chemistry. And as we go through this program, we'll probably see that chemistry deals with materials as physics deals with forces. And those are the two basic sciences. Mathematics helps us, geology uses us, biology uses us, but these are the two basic sciences, and chemistry in industry, chemistry in medicine, chemistry in agriculture is, has already been said, all pervasive. Society as we know it, the crowded society requires it. Without our ability to convert natural materials into other things that we use, the world couldn't support 4.8 billion people.
You touch on a very interesting subject when you bring up the medical center. A lot of people don't associate advances in medicine with a lot of advances that are made possible because of discoveries in chemistry. We're going to see a tape that really touches on one of these. It's called magnetic resonance imaging, and it may be the whole wave of the future. Let's look at this.
This is not an X-ray. It's a picture taken by one of medical science's latest diagnostic devices, using a process based on what's called nuclear magnetic resonance.
Here's the outline of the heart, which you can see entirely. These are the chambers of the heart. These are the vessels leading from the heart to the neck.
The National Institutes of Health near Washington, D.C. is one of a number of medical centers recently to go online with nuclear magnetic resonance for imaging the body and its abnormalities. Chemists have long used an NMR process to get analytical readouts on compounds, but taking pictures of the body with NMR is a relatively new application. High radiation and dyes aren't used. It works by placing a patient in a magnetic chamber This orients the magnetic nuclei of certain atoms, hydrogen in this case, toward the chamber's magnetic field.
What the physician then does is apply a second magnetic field that changes the orientation of those nuclei by 90 degrees. In this 90-degree plane, we can then detect the signal from this nucleus, and as it goes back to its normal position in the magnet, that's a signal that we detect, that we use to make pictures.
The time it takes the nuclei to return to normal position, relaxation time as it's called by chemists and physicists, plays a key role in the picture-making process. The nuclei of hydrogen atoms in different body tissues all have different relaxation times.
It is these differences in the relaxation time of each part of the body that translates into a high degree of contrast in the NMR picture that's obtained. That's why the docs are so excited about this thing.
The doctors are excited because now they have the ability to vividly see, for instance, a tumor in the brain or an infection in the skull.
This is the normal sinus area, but now you can see there's an area of a fungus infection which has actually grown into the area of normal bone cartilage.
NMR imaging, a new and valuable tool for improving the diagnosis and treatment of disease.
We have a tendency to think of chemicals in medical applications as being pharmaceuticals or things we do to our body, but it's very difficult, as we were pointing out, to draw a definite line between where your body stops and where chemistry begins.
It never stops. The fact of the matter is we're a mass of chemical reactions. Up in the head, in the heart, any place, liver. And a lot of people don't like that, perhaps. But we've learned an awful lot about brain chemistry, for example, in the last 4 or 5 years. We were able to, without invading, determine the production of a material called acetylcholine, which is a neurotransmitter. And it's quite obvious that unless our cells produce that at the right time for the particular purpose that we want it, we don't do what we want to do. I can't move my hand without that. So one of the very important prospects for chemistry is to unravel the business of what it is that makes us work the way we do. That may be a matter of concern. See, that begins to run into theology. It's a bad thing because that convergence can cause trouble.
Well, I don't think we do have any clear-cut lines among any of the sciences between theology and chemistry, if you will. You know, when I came out of graduate school, magnetic resonance, we were looking at simple hydrocarbon molecules, just trying to build a catalog of those things so we could identify simple things. Certainly didn't envision doing body scans with it. But I think this is an indication of what's happening with chemistry, as it is, as we've said, spreading into all the fields, whether it be biology with blood chemistries or any other field. You can't separate them. And I think this has some other ramifications, and one is the enormous complexity, if you will, of the instruments that you use, and you're pulling in every type of discipline, from computers to very sophisticated resonance spectroscopy equipment, and all of this then touches the whole field, and there's spin-offs, if you will, into all fields. I don't think you draw these lines anymore.
Well, actually, the chemistry was there all the time.
That's right. We're just picking up on it.
We named things in biology for a long time and tried to go. That was what biology was naming everything. Right. And that after we get to where we're beginning to understand it, we find out it's really chemistry. And so this is where we are today, and that's the reason progress is being made in the field of biology.
Well, take a look now. I'll go from that very esoteric kind of thing to a meeting I attended this morning, which had to do with a fairly new chemical process for treating sludge, for treating city wastes and industrial waste. One of the byproducts of chemical activity has been waste material. Not that humans don't produce plenty of waste without chemistry, without outside chemistry, that is. This process was designed to oxidize under supercritical conditions, which means beyond the critical temperature, a stream of sludge at rates of several hundred tons per day converted almost completely, 99.9% into harmless stuff, carbon dioxide, water, nitrogen oxide, and so on. Well, that's chemistry. That's at the other end. It's chemical engineering, in fact. It's a great example of first-rate chemical engineering. And there is a test that's going to be made here in the city at the Washburn Tunnel sometime next year or so of this process.
I guess that brings up a touchy subject probably for everyone here, and that's the bad image that chemistry has acquired over the years. It's been associated with a lot of the very noteworthy accidents, spills, and so forth that have captured an awful lot of media attention. And sometimes we seem to focus on the mistakes rather than all of the advancements that have been made, to the point where the mistakes become foremost in everyone's mind. As chemists, do you all feel that chemistry is getting a bad rap from the public and the image in general?
Well, I think what we should do, what's going to happen is the newspapers and the news people are going to call it a chemical spill, a chemical fire, and so forth. And whenever we come up with all these materials that we just talked about, we better say chemically derived, because if we don't, the public's going to think that what they want are those good materials, and they don't want those chemical explosions. And so we've got to educate the public that all of these things that we've been talking about are chemistry, and these are things that we have to contend with, and they're making every effort to minimize all those problems that we've had. And when you're dealing with the things that they deal with to carry out some of these reactions, these things are highly reactive. But to make a good material that we need, you have to start with highly reactive materials sometimes. And they are carrying them out safe, because this is still in the chemical industry. It's the safest manufacturing industry there is. But they do it with a lot of difficulty. You go into a chemical plant and they'll make you wear goggles and hard hats, and I even had the Carbide, I went in to visit them once, and to go back into the offices, it made me look at their safety film. And so that's the reason they're safe. And they're doing all they can to combat all these things, and they've learned a lot over the years. They did a lot of things that were wrong back there that gave them some of that.
The chemical industry, by National Safety Council statistics, every year is either #1 or #2 in the nation in terms of safety. You're 10 to 20 times safer at work in a chemical plant than you are in your home from home accidents. And those are the facts of working in the chemical industry.
And these are the kinds of things I think the chemical industry needs to get out, because there's this tremendous antagonism, if you will. And I see both facets of it, because I am and was a chemist, and now I work more as a naturalist and I suppose environmentalist. And the chemical industry hears the word environmentalist and they kind of bristle, and the people on the street hear all the chemicals and they worry about them. And there is no reason for that kind of polarization, and I think it takes a meeting of the minds. And I think both sides have to work at it.
Yeah, I think that's what this program is all about. Chemists in the chemical industry have recognized that we must communicate what it is that we do, take it out of the closet, and let people see what it takes to produce the materials that are so important to the lifestyle that we have and the continued improvement in the quality of life that we want. The solution to many problems is through chemistry, and it's created some problems of its own, but we've recognized that.
Which chemists must take care of.
And chemists must take care of them.
Solve them.
But we must let the public know.
Yeah, I think, and I think the public needs to be aware that the chemists are trying to solve them. I think that probably is where there's been some breakdown.
Another example in this safety, if it takes a person an hour and 20 minutes to drive to and from work, his chances of having an accident are exactly the same as if he worked all day long in a chemical plant. So that's another, and he's going to drive to work.
I take it y'all are very proud of your safety record.
Well, when you think of the difficulty of carrying out some of these things and the effort that they go to do safely, and in view of all the bad publicity we got, nobody realizes that. The only industry that's safer is banking. And
not right now.
Banking and insurance, the only thing that's safer.
But I wouldn't want anyone to think that we are complacent and that we're satisfied, because we're not, and we have a lot of programs going on to improve our responses to spills and to situations. We've got the CARE program going on that addresses emergency response in our communities. We've got legislation in the state to address the management of chemical waste and hazardous waste in the state. Because we are such a large producer of chemicals, we need a good program in the state of Texas to manage that material and to safeguard the resources that we have in the state.
It's kind of interesting. You know, we transport a lot of petroleum in a variety of ways, and that's dangerous stuff.
Yeah, I think when you consider the potential danger involved with the elements you're working with, it is quite admirable, the safety record that you have compiled. Another area of constant criticism about chemistry, and especially in the area of, for example, plastics, is the environmental problems that are posed since these things don't degenerate and we're left with these things on our beaches and so forth. We have a piece of tape that I think points out some very admirable work by chemists who are trying to find a solution to that chemical problem.
These empty plastic bottles aren't headed for the trash heap. Here at the Plastics Recycling Institute at Rutgers University, scientists are developing mechanical and chemical means for reclaiming plastic waste to convert it into useful new products. The Institute, established by Rutgers and members of the plastics industry, is on the leading edge in advancing the presently limited technology of plastics recycling.
Many plastic materials that are being used for consumer products in packaging and in other applications still have a great deal of their value remaining after they've been used once. And it's a limited resource, and as a result, we should recover those materials to use them in terms of their engineering properties as many times as we can, rather than simply use them once and throw them away.
To this end, in addition to laboratory research, the Institute has built a pilot plant to advance and demonstrate processes for recycling various plastics. Present emphasis is on recycling a plastic called PET, the principal material used in those soft drink bottles. Here, shredded empties are processed by air, water, heat, and chemicals to remove syrup, glue, and fragments of labels and caps. When they finally emerge, the plastic chips are ready for remanufacturing into a variety of products. Products like these. Plastics recycling is a fledgling field. Until the Plastics Recycling Institute, there had been little attempt at coordinated research, process development, or widespread implementation.
Our primary focus in addressing the issue of plastics recycling is to bring this technology to a much broader spectrum of the public and for the use and benefit of the public.
As plastics recycling technology advances, much of the waste that now winds up in landfills will be reclaimed, be used over and over again, until finally it's burned as a fuel.
I know probably one of the most frequent criticisms we hear about the chemical industry is made by people who walk along some of the Gulf beaches and look at the things that are strewn along the beaches. And you brought along a good example of where chemists have stepped in to solve a problem that's resulted from a chemical project.
Yes, I think the film pointed out there's a lot of things that we need to do. Probably an underlying core here is that this earth is the only one we have, and it is a limited resource, and we have to protect it. And recycling is certainly going to play a part. Waste minimization. Let's not even make those wastes if we don't have to. Back at the plant or in our own home, you know, education is going to play a part in how we manage that resource. But another situation that is being addressed by chemistry is some of the plastic waste that are produced. And what I brought tonight are plastic can holders that have caused problems in the past. This material is a photodegradable material, which means that if it is not properly disposed of and someone leaves it on the beach or in the water, for example, through sunlight action on it, it will degrade, and within 30 days it will be a flake like this, so that if an animal should come in contact with it, he's not going to be trapped. It's going to be a brittle material. It's going to break instead of trapping him. And so that's an improvement that we can make through chemistry. to help solve one of those problems.
John, I know that probably hits home with you because I know you have pointed out you've seen ducks, for example, that have had their heads stuck in those plastics.
Yeah, that's chronically been a problem, those types of plastics. And, well, as an example, last month, the environmental groups in Texas mounted a volunteer effort to clean some 150 or 160 miles of beach in Texas. And in just a few hours picked up 300 tons of waste from our beaches, of trash, about half of which was plastic materials. And that's been the problem, is that they just don't biodegrade. And so a styrofoam cup or a plastic six-pack top like this is going to be out there for years. This kind of thing can certainly help. But I think the other thing, and this is what the film pointed out on the recycling, is that we need, I think, to build in this, and the chemical industry can help with this, a recycling mentality rather than a disposable mentality. As you said, Karen, this, you know, we only have this one world, and if we can take fewer things out of it, but keep our chemical industry going by the recycling of it, we should not only have cheaper things, but we do conserve, and then we solve some of these environmental problems. And that's, perhaps the recycling isn't going to stop somebody in a ship coming into the Gulf of Mexico from throwing a plastic bottle overboard, but we do need to start somewhere. And I think this is what the chemical industry needs to convince the people, is that they really do care. You know, chemists aren't set aside somewhere doing their chemistry and the rest of the public goes about their daily life. Chemists live a daily life too, and they also care about what's on our beaches. An awful lot of chemists take their families to the beaches too. They do care, and there are ways to approach these problems, and I think we need to merge our interests that way.
I'd like to point out that the chemical industry itself has done a lot in the last 5 years. They generate now 50% less solid waste to dispose of than they did 5 years ago. So they're cutting down on the problem, but just not generating.
Well, I think chemical industry as a whole has embraced the concept that the responsibility goes from the creation to the grave, and we do have a responsibility to worry about those processes that are byproducts from the products that we're seriously interested in. Waste minimization, I think, is the proper term at this point.
I might just point out that on the beaches wouldn't be littered if people didn't throw the stuff out.
Well, education, of course, is going to be a part of the solution to the problem. Is let's proper waste management if you have a material that needs to be disposed of. And I'm of the opinion we need to address our problems today and not leave them for somebody to take care of in the future.
Are you pleased, John, as a chemist who has now, I guess some people would see it as joined the enemy camp? You're now a naturalist, and some people would say those two careers are really not compatible. What's your view as a naturalist looking back at chemistry?
Well, I think they are compatible, and that's what I've been trying to stress, is there shouldn't be this kind of an opposition and polarization. And, you know, I don't go to a bench anymore and put chemicals into flasks and try to come up with new plastics, which is one of the things that I worked on. But that kind of training certainly stands me in good stead in any kind of discipline, whether it be trying to, you know, photograph some rare animal or looking at an environmental site and finding out what's happening to it. I don't for a moment, you know, begrudge my chemical training. But I don't think there needs to be this kind of polarization. That's the point that I'm making. I think there is. I think there is too much of a polarization between what, for want of a better word, I'll call the rest of society and the chemical industry. And I see no reason for that. The problems are hard and they're complicated, and I know too many people who call themselves environmentalists, and I guess I do call myself that, but who are anti-this and anti-that, kind of reactionary about it, and it's their first reaction. And yet they want to hop in their automobile made out of you know, refined metals and plastics with fuel in there and oil with all their chemical additives and go bird watching. So they want to use it too, and they're as dependent on the chemical industry as anyone else. They don't do anything without chemistry entering their lives. And so I don't think there's any, should be this polarization that there seems to be. As Dr. Hackerman said earlier, chemists are going to solve some of those problems too. Hopefully all of them. I'd like to be that optimistic. But it's an ongoing program. But I think something like the recycling interests, something like that we saw in that film can lead into that. And I think really we need some mutual trust and respect. That sounds a little hokey, but I think it's a place we need to start.
I think most of the things that the chemical industry has been involved in has been started on the basis of trying to solve some basic human problems, whether it's food, whether it's housing, clothing. The things that the chemical industry started were to solve problems. Now there's been some problems created as a result of that. I don't think there is any basic disagreement
No, I
between what
don't think so either.
chemists are trying to do with chemistry.
If there weren't a demand for that, the company would have gone bankrupt in a hurry and started making those things.
Well,
there is a demand, and that's what they're meeting.
I think the chemical industry has taken a more responsible position. They have realized that you can't hire a third party to get rid of the waste. They found out that they go dump it somewhere and then the company has to go clean it all up. So they are looking at handling all of their, very few of them now are letting another company handle their waste. And they're looking at everything and trying, and they're even getting to where they feel responsible for the product even after people get through using it. So they're taking I think they're taking a very responsible position in these matters.
And this is not necessarily in response to pressure from the government or anyone else. I mean, it seems to be that this initiative is coming from within the industry.
And within the people themselves. Come back, chemists are people like everyone else, and they have the same concerns. And I think they're environmentally aware too. And I think the person in a chemical industry is probably as aware of what's happening in the environment as the guy who drains the oil out of his car and goes dumps it down the storm sewer. You know, people do things. It's just that the chemical industry has to do it on a bigger scale. And consequently, once in a while, they have a problem to solve. But they're aware.
I think the point that these are people, they're neither magicians nor monsters, which is the way they're looked upon. They are just people. And they have as many interests as any other people. So their interest is in maintaining a properly clean world and not in contaminating.
I guess, Karen, there would have been a time when there would not have been an environmental services person necessarily at a chemical company. Is that something that is reflective of this responsibility?
Well, I'm not sure that that's totally correct, because we've had a toxicology department studying the effect of chemicals on people and animals for over 40 years. So we go back a long ways in the environmental responsibility area.
I think it's important to remember that people didn't know roughly before 40 years ago that there were things that give you trouble. When Perkins discovered dye, he made dyes, and people bought them and used them, and they were dangerous. Nobody knew it at the time. Now they do, so they take care of them.
Nobody knew about the asbestos, vinyl chloride.
They didn't know about asbestos. That's right.
And so these weren't things that have been done in the past, weren't done intentionally. And when Mac Pruitt used to be head of research when they established that triangle down there, he said the next chemical that causes cancer, we want the chemical industry should find it out first instead of having the public find it out. And so they've taken that position, and it's up to them to determine whether or not their chemicals are harmful to the public.
There is another newer area of chemistry that has a lot of people raising their eyebrows over, and that's this area of gene tailoring. And it's an area I'd like to hear your comments on. First of all, we have a piece of videotape that I think kind of capsulizes what's happening in this very new area that's called gene tailoring.
On a TV monitor, an agriculture department scientist is seeing what his microscope has blown up 15,000 times, a petunia cell that he's injecting with gene-bearing chromosomes. The process, called microinjection, is a recent biotech innovation by which researchers are hoping to genetically engineer better strains of plants from blocks of genes.
What we're attempting to do is take chromosomes from a selected species of petunia and inject those via a microscopic hollow glass tube into another species of petunia. In doing this, what we're trying to do is identify the genes involved in traits like resistant to sandy soils or drought.
Microinjection of itself seems simple enough. It's the preparation of the plant cells that's complex. First, getting inside the cell. This requires using enzymes to chemically peel away the tough cell wall. Next is the tricky problem of removing the cell's vacuole. That's the large mass inside that holds wastes and if punctured by the glass tube would contaminate the cell. To resolve this, the cell or cells are spun in a centrifuge. That forces the vacuoles out of the cells without breaking their membranes. The vacuoles, by the way, will soon grow back in. With all those preliminaries finally over, the cells are then injected with the chromosomes carrying the desired gene blocks and left in tissue culture to grow. Dr. Griesbach, who developed much of this technology, currently works with petunias because they're one of the few plants that can be regenerated in tissue culture from a single cell into a whole plant. Ultimately, what may all this lead to?
One of the things we're attempting to do is develop a new genetic engineering system that will transfer multiple genes. The current genetic engineering techniques will only transfer one gene at a time. This technique hopefully will be able to transfer these blocks of genes involved in disease resistance or resistance to stresses like drought.
Microinjection, genetic engineering from a different approach.
For a lot of people, the specter of chemistry rearranging our genes, not only in plants but potentially in animals and in humans, is kind of scary. Anybody like to pick this up?
Oh, I think it is so exciting that while we recognize there are some significant problems with it, it's still something that we just must get into. Food production, I guess, is one of the fields that I've had an interest in for a long time. And the opportunity to make major changes in food crop production through this kind of chemistry changes can lop years off of improving a crop. The potential for crops to fix nitrogen, which don't now, and therefore you can't repeat them on a regular basis without wearing out the soil, is one of those kinds of opportunities. Developing disease resistance for the crops is a tremendous potential just by changing the genes in the plants themselves, and those can be tailored.
A lot of people will react to this and say that aren't there some ethical considerations when we start transforming living organisms?
Certainly there are, and I think the thing we have to do is engage with the public, with our governments, with the scientists in determining what those things are that need to be given their proper attention. But I think the opportunities are so great that we must continue.
Consider the other side. I said there are about 4.8 billion people in the world. It's estimated it'll double in about 30 years. The planet is already stressed in attempting to take care of 4.8 billion. How will it take care of 9.6? Unless we find a way to make it more fertile, so to speak. So you're not going to get this benefit without cost. And I hate to sound like an economist, but you do have to do a cost-benefit analysis. Do you gain more than you lose? Do you gain enough more than you lose to make it worthwhile going ahead to do it? Fact is, nobody else has any inkling of an idea as to how to take care of nearly 10 billion people. A lot of them are starving right now, as a matter of fact, for a whole variety of reasons. So if we hesitate to learn more than we now know, culturally we're making a bad mistake, and pragmatically we're making a bad mistake. We need the ability to wrestle out of the earth the food and other sustenance to take care of as many people as are likely to be on the face of the earth. Somebody might tell you that when the earth gets too crowded, one of the four horsemen will take care of it. Pestilence or some problem, something like that. But we've got to the point where we sort of intersperse ourselves between the natural disasters that visited the planet in the past, because we know a lot more. Now, if you're saying, should we not know so much, then you're asking a very serious question. Ignorance is not the end of our existence. That's not what we should look for. We should look for ways to reduce ignorance. And I think anything that diminishes our insatiable interest in new knowledge is contrary to our appropriate existence.
Are there some downsides, though? You talk about the
Of course there are.
equation. What would be some of the downsides that we have to contend with?
Well, clearly, in anything that we do like this, where we're not fully aware of what's going on, because I can use a theological argument. When we know everything, we're going to get wiped out and start over again. But we don't know everything. The systems we deal with are obviously very complex, much more complex than we've ever dealt with in the past, the human system. Therefore, our ability to be able to predict totally knowledgeably that the introduction of a splice to the gene, while it will do a whole lot of good, won't do any damage at all, is just impossible to do. Consider, there are a lot of people born with genetic dysfunction. Potentially, gene splicing can help solve that problem. Do you stop thinking about that? Because some place there will be mistakes. The history of the human race is that you don't stop thinking about it, you do it. You continue.
Does this appear to be, say, the most exciting frontier that's in the area of chemistry, this area of manipulation of genes now?
I don't know that that's necessarily the case. I think if we did not pursue it, it'd be just like the Dark Ages. That's what they decided they didn't want to learn anymore. And I think that learning more about how biology or chemistry is associated with biology is helping us in all the chemotherapy and so forth, because we're getting drugs that are more specific. And the thing that hurts you now in chemotherapy is it's killing a lot of good cells as well as the bad ones, and you're just trying to get, we'd like to get drugs that are more specific on all these things. And so it's still the same problem of understanding the entire picture. And we just must proceed in the direction of learning more about all these things, or we won't go anywhere.
The pursuit of understanding is a very normal human drive. He mentioned the Dark Ages. There was a Cultural Revolution in Red China, same kind of thing. So every once in a while there's an obstruction to this drive for understanding. But almost always, always it has continued.
I think one of the things that's helpful in reducing the risk is the techniques that are available today for making predictions about what's going to happen, and the computer has made a major change in that. One of the tapes that we didn't look at was one looking at the use of computers in order to design chemical compounds with specific capabilities. That same kind of computer technology to do massive thinking about what the possibilities are can reduce the risk significantly.
And by the way, the computer cannot operate without chemistry. It is not fully electronic.
If this is just one of the many frontiers, let's talk about some of the others. What are some of the other areas where we're potentially breaking into some new discoveries before too long?
Communications is a field where chemistry plays a significant part, and communications is so important today. And the capability to transmit large numbers of signals in small numbers of cables is in part a development of the chemical compounds that will allow that to happen.
In fact, you can go a little further than that. The current microelectronic, the chips, have lines of the order of a micron. I can't remember what that is in inches right offhand, but it's pretty small. It's less than a thousandth of an inch, considerably less. To make a major change at the present time requires that you go down to molecular sizes. And the chemists are dealing with molecules that have memory, have the capacity to give signals under a variety of conditions, under light conditions, for example, sound conditions. And those molecules are tailored to provide the kind of signals we're talking about. Now, they're way off. But the fact is that at some time there will be molecularly driven computer systems.
When we look at an area like genetic tailoring and so forth, And then we look at other areas, as I think you mentioned, Dr. Holland, about asbestos, where we learn after the fact that there are dangers. Have we learned lessons from those experiences that we're now applying toward the future?
Yes, I'm sure we have, because everybody's got concern with toxicology now, and there's an institute set up just to understand it better. And it's supported by a lot of different companies in Raleigh, North Carolina. And their objective is to find out before it's ever put into practice. And so they're acting, they've had these bad experiences, so they intend not to have them again. And also there's a review that it turns out that the deaths that have been predicted by asbestos hadn't been nearly as bad as they thought it was going to be. And the same thing with vinyl chloride. I was just talking to somebody on the Air Quality Control Board the other day and said they just looked at all the numbers on that. But that doesn't really excuse it, but we want to find these things out before they happen.
When you look at the people that are going to be necessary for these advancements to take place, are these people coming along in chemistry? Do we have the system in place now to produce the type of future chemists that we need?
We have the structure. What's happened over the last 3 or 4 years, the enrollments have gone down each year because of the recession. And companies had to cut back to get efficient again. They'd overhired. And they're just now beginning to pick up, but the structure's there. There may be a shortage of engineers and chemists coming up in the next few years because of the fact that it takes 4 years for this cycle to take place. If you have a recession, we have a recession down here in Houston in spring. We feel it in the fall enrollment at A&M. And then it takes 4 years for that class to pass on through till you get another class. So it's got a 4 years lag to it.
We have a few minutes remaining in the program, and I think it would probably be an interesting time to have you look into the future, if you could, and in view of the things we've seen happen so rapidly in the last few decades, really, in the area of chemistry. Dr. Ackerman, when you look into the future, what do you see coming as a result of chemistry?
Well, it may not be as pleasant a prognosis as you just heard. See, I happen to think at the present time that there's a very seriously diminished interest in chemistry and science generally by students. Not so much in engineering as it is in the sciences. And unless we learn how to turn that around and get 9 and 10-year-old kids interested again in the sort of magic of nature, we won't have to worry, because we won't be doing any chemistry. So my concern about the future is that we somehow develop a proper system for interesting young children, not in chemistry, but in nature, in natural phenomena, and then develop the chemistry or the physics or whatever it is as they pass on into college. As far as the potential future is concerned, we are now very comfortable dealing with very small fragments of matter. With an individual molecule, we can see individual atoms now. We use a scanning tunneling microscope and watch an atom move across the surface. We're pretty sophisticated. Maybe not as sophisticated as we can be, but much more than we were even just 20 years ago. And because we're able to do that, because we have the instrumentation, and because chemistry is a science of matter, we have a whole panorama in front of us that we can work in almost any area with the instrumentation we have, do what we want.
Okay. Karen, what do you see when you look into the future of chemistry?
I look at the future in the state of Texas, and I see Texas poised for, with our framework of the chemical industry, for many new jobs in this area. But from my perspective, I see that that can only happen in Texas if we have the trust of the people. And we don't get that trust. We have to earn that trust. And from my perspective, the key to that trust is how we manage our environment. That's going to say whether this industry grows in the state of Texas.
Okay. Bob, what about you?
The field of chemistry has a tremendous future, I believe. Maybe I see it developing worldwide more clearly than I do in a specific location, because what happens with the chemical industry in a specific location, as Karen points out, in a large part is dependent on the relationship between the people and the industry. But the solution to major problems in the field of medicine, food production, materials for the basic research and exploration and discovery are still going to come from the chemists. So it's still a very exciting opportunity.
Same excitement, Dr. Holland?
Yes, I would say that in the commodity chemicals that we've got an opportunity to get the market, which is to be about a 30% increase by 1995. And then, in addition to that, there's additional specialty chemicals, pharmaceutical, and the bio areas that is coming on. And if we get the public along with us and receptive to the chemical industry, we can get that. Plus, there's all these final product industry, the consumer product industries that this state hasn't touched, that we should be getting into because they're people intensive and we need it for our economy. So I see that future out there if we can grasp it. The opportunity's there. And so we need to get out and sell chemistry to the public and get on with it and get the economy going. And this is a real basis, one of the best opportunities and basis for doing it, I think.
John, what about from your vantage point?
Well, specifically, I can't imagine what's going to take place in the next 30 years. I've watched chemistry for 30 years. I can't begin to guess the products and the processes that will be developed in the next 30 years. But I think, you know, it's bound to be enormous. But I'd like to come back and address this problem if we can get the public interested. We need new chemists. We need people working on these. And I think that this is what we need to convey, too, is that this is exciting and it is fun. Any kind of research, discovering something new, putting together something new is tremendously gratifying. That I think we need to stress. And then we need to stress that chemists are concerned about, you know, the problems we've talked about, genetic engineering. And sure, it's going to cause some problems, but these can be solved. And the future is incredibly exciting. What it means in terms of a specific compound, I have no idea. I don't know what my car will be built out of 30 years from now. I have no idea. But it will come from chemistry, certainly.
Well, thank you all for sharing your excitement about the future of chemistry, and I think we all who have heard what you have to say share it with you. And thank you for watching.
Funding for this program has been provided by the Southeastern Texas section of the American Chemical Society and Friends of National Chemistry Day.